Hello, so we are live again for the next NMAT session. Right, so therefore, another set of problems to practice with me, right? For those of you who are watching it later on, I would again remind you that it helps only to pause and try before we look at the solution. And for everyone who is with me on this session, as always, keep on trying as we go along. All right. Last lap. So therefore, uh, just another time, another crunch time, and we should be practicing full throttle on all the topics. All right. So here we go. So just to remind you that Snap, Zant, NMAT online classes, we have a module for that. So you can look out for the details, and if it helps, I would suggest that you can go for our module. Okay. Okay, so we are starting ratios. First question. Okay, so right, we will start with the first question right away. The ratio of incomes of A and B 6:5. The ratio of their expenditures is 2:1, and the ratio of their income of their savings is 2:3. Okay, all the three ratios are given. No number is there. So we have done this many times that whenever numbers are not there, we can always assume, right? What is being asked? What percentage of his income does B save? Let's see. So income is expenditure plus savings. That is the only thing that works in all these questions, right? So income is expense plus what you save. So we can start by assuming the income. That would be the most convenient thing to do. Let us assume the incomes of these two people, right? Let's say 6:5, 600, 500, right? Always works, taking it to be in terms of hundreds, right? So their expense is in the ratio of 2:1. So expense of A is twice of that of B. So if this expense is X, then this expense is 2X. And the ratio of their savings is 2:3. So therefore, 2:3. So 2Y, 3Y, right? And then we can apply the equation that income is expense plus savings, right? So that should give us the values of X and Y. And hence we can get to find this percentage, right? Of what percentage of his income does B save. So our equations are therefore that 600 should equal 2X plus 2Y, or simplify further that 300 should equal X plus Y is the first equation. Second one, 500 should equal X plus 3Y. Very simple equations, just subtract and get the values. So 500 equals X plus 3Y. This is equality sign. This is also 300 equals X plus Y. Subtract 500 minus 300, 200 equals X cancels 3Y minus Y, 2Y. So Y is coming to be 100. And that is all that we want to have, because this is what we need. What percentage of his income does B save? Out of his income of 500, he's saving 300, that is 60%. Right? So a typical question of income, expense, savings, right, presented in the ratio form. Again, assume the numbers and proceed. Since expense and savings ratios, they are independent parameters, so we had to take different ratio constants. Obviously, we cannot say 2xx and then we cannot say 2y 2x 3x, right? It has to be taken as a different ratio constant. Don't forget that, right? And then it was usual. Perfect. Okay, so I know a lot of people are there in the session. I have set up the mood, so let's see if you can get the next one. Okay, so I am also starting. You also try with me and try to give me the answer faster than I can solve it. Right? The number of four-wheelers, three-wheelers, and two-wheelers produced by an automobile manufacturer during a certain year are in the ratio 4:5:6. Three things, the ratio. Owing to changing demand, in the next year, the company decides to increase its four-wheeler and two-wheeler production by 25% each and decrease the three-wheeler production by 20%. Okay, so percentage changes are happening to the numbers. What is the percentage increase in the total automobile production? So Two of the things are increasing, the other one is decreasing also. Overall, there should be net plus change, right? Right. Let's see. So four wheelers, three wheelers, and two wheelers are in the ratio of 4 is to 5 is to 6 in that order. So therefore, if I take the number of four wheelers, again 4 is to 5 is to 6, so I'm taking as simple numbers 400, 500, 600, right? So what is the total? 1500, right? Because on that denominator we will observe the percentage change, right? So the initial total number of vehicles I've taken to be 1500. Now they will change, right, such that so four wheeler and two wheeler, each of them increase, right, by 25%. So this is plus 25%, this is plus 25%, right? Which means that this will become what? 500, 400 into 1.25, one fourth of 400, 100 increase, one fourth of 600, 150 increase. So 600 will become 750. And that three wheeler will drop by 20%. Again, very simple. 20% means one fifth of 500. So it drops by 100. So 500 will go to 400. 5 and 4, 900, 9 and 750, 1650. So that's an increase of 150. 10% done, right? 150 is the net increase on the base of 1500. So 1/10 or 10% is the increase, right? So both the questions were quite similar. Ratios is given, take the numbers, proceed, right? Because working with numbers is easiest, right? Perfect. Okay. Mixtures. Next one. Okay, so a box contains a total of 30 kg of rice of three different varieties A, B, and C. After 8 kg of A and C in the ratio 3 is to 1 and 8 kg of B are added to the box, the ratio of A, B, and C in the box is 8 is to 10 is to 15. And we are asked to find the initial ratio of A, B, C in the mixture. In this question, if you start from the initial things, you have to take three variables and create equations with them. Again, my motive is how to be fast. You can be fast by not creating variables, not creating equations. I mean, sometimes that does become necessary, but what I'm saying, you know the ratio at the end, 8, 10, 5. You also know the total weight, isn't it? So you can find the numbers directly from the last stage and then backtrack, right? So with this question, the very important thing that I'm trying to tell you people, if you want to be fast, if you want to crack this exam, you need to work with numbers, right? You need to stop using variables and equations as far as you can, right? So therefore what I'm saying, 30 was the initial total weight, right? Then you added 8 kg of A and C and then another 8 kg of B. So 30 plus 8 of A and C combined and 8 of B combined. So 30 plus 8 what? 46 is the total weight in kg of the final mixture, which is split across A, B, C in the ratio 8 is to 10 is to 5. So you need to split 46 in this ratio of 8 is to 10 is to 5. I think that's very basic. 8 plus 10, 18 plus 5, 23. 8 plus 10, 18 plus 5, 23. 23 into 2 is 46. So just double these numbers. Those are the actual weights in kilograms. After all that, A, B, C have been added to the box. So this is actually 16 kg. This is actually 20 kg. And this is actually 10 kg. Now, this is the final situation. We have to backtrack the initial situation. Now, therefore, we need to remove what we had added to find the initial distribution. We had added 8 kg of A and C in the ratio 3 is to 1. So 3 is to 1, 3 plus 1, 4 into 2, 8. So we had actually added 6 and 2 kg, right? So now remove 6 and 2 kg from A and C. So minus 8 and minus 2, right? So this becomes 8 and this becomes 8 as well. 8 kg of A and C in the ratio of, sorry, 3 is to 1, 6 is to 2, sorry. This is 6 is to 2, minus 6. So this is 10, right? 3 is to 1, so 6 is to 2. So remove 6 and remove 2. And 8 kg of B, so just remove 8 kg from here. So 20 minus 8, 12. So those are the initial values. So therefore, 10 is to 12 is to 8, or 5 is to 6 is to 4. There is your answer. Isn't it, people? Give me a yes, right? I hope this makes sense, and this is the way to deal with it, right? Just deal with numbers. Okay. Okay. So therefore, that's the way to go with such questions. Here we go with the next one. Linear equations. Now, a very different kind of a question, this one, not a usual one. Let's read it together. Cows are allowed to graze in a grass field in which grass grows at a certain constant rate every day. If 10 cows graze in the field, the grass will be completely consumed in 20 days. Instead, if 15 cows graze in the field, the grass will be completely consumed in 10 days. The more the cows, the less the number of days required, isn't it? The more the cows are there, the more quickly they will be eating up the grass and finishing it up, right? In how many days will the grass be completely consumed if 30 cows graze in the field? So important thing is to understand that what are the things happening over here. There's some initial amount of grass, obviously, that we begin with, right? If there is no grass initially, how can the cows start grazing, right? Again, there is no numbers, nothing, no quantity. I'm taking it to be 100. What? I'm taking the initial quantity of grass to be 100 units, right, on the field. Then there are two things involved here. One is the rate at which the grass grows. Remember, grass grows at a certain constant rate. I'm taking that to be X. Let's say X is the rate of increase of grass on a daily basis, right? Rate of increase of grass on a daily basis. So the grass increase per day, I'm taking it to be X units, right? And obviously there is a rate at which the cows are grazing the grass. So Y, let's say I'm taking to be the rate at which the cows are grazing. Grazing means the grass is being eaten away, removed, right? So this is a negative change, right? Again, this is the rate of decrease. So this is a minus change on the grass per day per cow, because it depends, right? The more the cows, the more the grass will be grazed. So I'm taking the Y to be per day per cow change in the basically this is the consumption rate, right? So effectively in that there are two scenarios defined over here, and we have taken these two variables. We have to find them. So we have to create equations on that. It's a very different question, I know. This is something that I'm taking a little longer time because it's a new question, but once you get the hang of it, if you get this kind of a problem, you can do this very quickly, because it's only equations that you have to frame correctly, right? Once you frame it correctly, doing that mathematical job is not a hassle, right? So what are the equations? Obviously the grass is being eaten away completely, so whatever is the total uh, you know uh, the total grass that gets generated on the grass field, the total initial grass plus the what gets generated by the per day change, per day increase in grass, should equal what is being consumed. So that's the equation. So first equation will be 100, the initial quantity of grass, plus it took 20 days to completely consume. So X is the rate. So 20X units will be produced, right? Should equal what was consumed. Now this rate Y is per day per cow. So this Y needs to be multiplied with the number of days and the number of cows, right? So there are 10 cows. So 10 into, 10 Y, you can say 10 into Y is the amount of grass being consumed per day, and then in 20 days 20 times of that will be consumed. So this is the equation we have. 100 plus 20x should equal this 200y. I guess 20 can be cancelled off. To simplify this equation simply as 5 plus x equals 10y is the first equation. Perfect. 20 can be cancelled. Likewise, we can create one more equation. So you got this equation, right? Everyone, just please, any doubts? If you want me to repeat, I can do that, right? That's the whole point, right? So far, I hope everybody is with me, right? Likewise, we can make the second equation, that again 100 plus. So now 15 cows took 10 days. So 100 plus 10 days. So 10x will be, generated, should equal again the same way 15 cows. So 15 into y is the consumption per day, and 10 days, so into 10. So this is 150y. Again, we can cancel 10 and we have that 10 plus x should equal 15y. Simple equations, just solve them, subtract, x will cancel obviously. So 5y is simply 5. Y is coming to be 1. And if y is 1, then putting it back over here, x is coming to be 10 minus 5, 5. Okay. Now, the question is asking that if there were 30 cows, how many days they will need, right? So now we have to come to the third scenario and we have to create the equation for that, isn't it? So 100 plus, if the grass is consumed in n days, so 100 plus x equal to 5 is being produced per day. So 5 into n will be produced. Now, what is the variable n? N is the number of days, right? In how many days? So x, which is 5, has come across as the rate of increase. So 100 plus 5n will be produced and should equal what is consumed. Since there are 30 cows, so at the rate of y, which is 1, 30 units will be consumed per day. So 30 units, and n days, 30 into n will be consumed. Okay, so that's it. 100 plus 5n equals 30n. So 25n I'm getting to be equal to 100. N is coming to be 4. Right? So in 4 days, this will be consumed. Isn't it, people? So what do you say? Right? Done? Makes sense? Isn't it? A very different kind of a problem. So you see, what I'm trying to do is that, showing you the typical tricks as we did with the first few questions, how to deal with ratios and how to not use variables. And I'm also exposing you to some new style of questions, something that, if this becomes, something that adds up to your repository, right? If you get this kind of thing, you know how to do it. Perfect. All right. Next one. Quadratic, right? Quadratic. Okay. If the quadratic equation x square plus kx plus 16 equals 0 has integer root or roots, then the number of possible integer values of k is how much? So question on quadratics with the integer condition on the roots, right? Roots are integers. How many values of k are possible? K is the coefficient of x. We know the constant term is 16. Coefficient of x square is 1. So it's an upward parabola, right? Simple. So obviously all of us know an quadratic equation is of the form x square minus sum of the roots into x plus product of the roots equal to 0, right? So that is the relationship between the coefficients and the roots, right? So already x square quotient is 1. So therefore we can directly interlink over here that product of the roots is 16. So if the roots are, let's say, a and b, so a into b is 16 and they are integers, right? And we have to find the values of k, and we know that k is negative of the sum of the roots, right? So k will be nothing but minus of the sum of roots. So just we have to figure out all the possible combinations of a and b over here, isn't it? So product of two integers is 16. 16 is nothing but 2 power 4. So just we have to split 16 as the product of two numbers, all of which have to be obviously multiples of 2. I mean powers of 2, right? So if A is 1, B is 16. What will be the value of K? Minus 17, right? Negative of the sum of roots is the value of K. We can do 2 and 8. We can do 4 and 4 also. So 2 and 8, so minus 10. 4 and 4, so minus 8, right? But remember, the roots are integers, not positive integers, not natural numbers. So 16 can also be said to be the product of negative 1 and negative 16, in which case K will take the value of 17. Similarly, minus 2 minus 8 is possible, 10. Minus 4 and minus 4 is possible, 8. So how many values we have? We have 6 values, right? 6 values of K are possible such that the roots are integers, right? In the middle two cases, 4 and 4, the roots are the same. So that is why it is written integer root or roots, right? Isn't it? Perfect. Okay, here we go. Next one. Indices and surds. Okay, so this question is also very common that might pop up, right? To compare surds, right? These are all surds, right? Fractions of powers of integers. So you have to compare and find the largest amongst these 5 options, which is 5 raised to power 2 by 3, 2 raised to power 3 by 2, da da da. Now look at the powers very carefully. So the point is we cannot calculate each of these numbers, but we have to bring them to a common platform so that we can compare. Look at the fractions 2 by 3, 3 by 2. Can you see one pattern over here? All the denominators are 2, 3 or 6. So the common multiple of that is 6. So whenever you have such a question, look at the powers and their denominators specifically and take their LCM, right? So my point is express each of the powers as x by 6, something upon 6. So for example, 5 power 2 by 3 can be therefore also written as 5 power 4 by 6, right? So we have to bring them to the common thing, and that common platform is equate the denominators. So that can help you to then compare the numbers. Likewise, 2 power 3 by 2, so 2 power 9 by 6 multiply by 3. This is already 5 by 6, perfect, no issues with that. 11 power 2 by 3, 2 by 6, and 7 power 1 by 2, so therefore 3 by 6. So therefore, power 1 by 6 is common to all, right? So therefore, this basically becomes 5 raised to power 4 whole power 1 by 6, isn't it? When you have a power, so we know, I mean, I'm making use of the rule a power m whole power n. Power of power, powers get multiplied. So a power m whole power n is the same as a power m into n. So if it is 5 power 4 by 6, it is as good as 5 power 4 whole power 1 by 6. Right. So therefore, all of the numbers are now like something power 1 by 6. So whatever is in the brackets that we can compare, 2 power 9 whole power 1 by 6, 3 power 5 whole power 1 by 6, 11 square whole power 1 by 6, and 7 cube whole power 1 by 6. So whichever is the largest amongst all these numbers in the brackets is the largest value. 5 power 4 is 625. 2 power 9 is 512. 3 power 5 is 243. 11 square is 121. 7 cube is 343. Option A makes sense. 625 is the largest amongst all these, isn't it? So that's a very common trick how to compare surds, right? So you have to equate the denominators on the fractions. Whichever number is then the largest in the brackets is the largest value, right? Perfect. Okay. Next one, modulus. All right. So modulus again, I find that students typically are little bit uncomfortable with this topic, but let me tell you, if you know the basic, modulus opens in 2 ways. So open the modulus in those 2 ways and solve, right? How many solutions exist for this equation? So a quadratic is in there in the modulus and then equal to 12. Look at this very carefully. When you open the modulus, the modulus opens as per, a criteria, a condition. So whenever you're opening the modulus, be very careful about uh, you know uh, that whatever solutions you're getting after opening the modulus, are they valid or not. So my point is, this is a quadratic, right? So forget the modulus. What will be the graph of this quadratic? An upward parabola. If I say fx is x square minus 12x plus 20, which also has a very easy factorization, because this is 10 to 2 and this is 10 plus 2. So fx is basically nothing but x minus 10, x minus 2. So its roots are 2 and 10, right? Isn't it? So its graph will be like this, with 2 and 10 being its root. This is 2, this is 10. Now this is fx. But what we have done, we have written mod x, right? So when we take the modulus, what happens is that the negative numbers get replaced with their positive counterpart, which means we replace this negative portion, this negative range of the graph, with its positive values in the same magnitude. So something like this will come across, right? So this is the graph of LHS, right? Mod of x square minus 12x plus 20. Now this equals 12. Okay. So the point is that this modulus will open in two different ways. So when your x is either less than 2 or more than 10, so it will open with the positive sign, because that already is the value which is positive. So when x is less than 2 or x is more than 10, our equation will be that x square minus 10 12x plus 20 equals 12, because that expression already is positive. But when x is lying between the roots, then your fx, the original function, the quadratic function, was negative. So when your x is lying in that range, then your modulus will open, right, with minus value, minus of this. So your equation will be that negative of this. So minus x square plus 12x minus 20, right? Negative of this is 12, right? So just solve these two equations and just be very sure that those solutions are also, are they, I mean, if you get the solution, so you'll get quadratic, right? You'll get two solutions. Are those two solutions also matching with the range above? If they match, then we'll accept them, else we'll reject them, right? So therefore, let's continue this solution of both these quadratics. So thus the first one is x square minus 12x plus 8 is 0. 20 minus 12, 8. Okay, so am I getting the factorization over here? No. So let me calculate this. What are the values of x that I'm getting? X is coming to be 12. Now I'm using the quadratic formula, minus b plus minus root b square minus 4ac, that formula, right? So minus of minus 12, 12 plus minus under root b square minus 4ac. So 12 square 144 minus 4 into 8 32 whole upon 2, 2a, right? This is 112, right? This is 12 plus minus root 112 over 2. 112 is, we can take 2 common and cancel that, right? So this is, I can write this as 12 plus minus 2 root. So divide by 4. 4 3s are 4 2s are 8, and then 32. So 28 by 2, right? Okay, so this is finally 6 plus minus root 28. Now, are these roots falling in that range of less than 2 and more than 10? Just check carefully. Approximately 6 minus root 28 is approximately how much? This is something like 5 point something. So maybe 5.1, 5.2, because 28 is, 25 would be, square root of 25 would be 5. So this is 28. So something like 5.1, 5.2. So this is 6 minus, let's say 5.2. So this is approximately, let's say something like 0.8. So yeah, it is less than 2 for sure. And 6 plus root 28. So 6 plus 5.2 approx. So 11.2. So yeah, that is also following in that range. So both these solutions are acceptable, right? So we get two solutions from here. Likewise, we can check with this. Everybody is saying 4 solutions. Yes, Arup. Yes, Sushant. This will also give us the 2 roots which are valid. You can see we're getting x square and minus 12x and plus 32 is 0, right? So x square minus 12x plus 32, which has a very easy factorization of x minus 4, x minus 8. And therefore, 4 and 8 are the roots, which are both falling in that range only of 2 to 10. So we get two more roots from here, which are valid, 4 and 8, right? So therefore, we have 4 solutions and 4 is the answer. Perfect. Okay. Now, next one. Let me pause for a minute and give you a minute to try this. Okay. You can solve this directly from graph. Yes, Arup, I know that. I know that. I know that. The maximum for this is 16. Yeah. So there's a graphical explanation also over here. And in fact, I like the graphical approach, right? Okay. So something interesting here. Let's see. All right. Now let's check out. Share me your answers if you getting them. Rohan, Sohan, and Mohan invested sums, means principal amounts, basically, in the ratio of 5 is to 9 is to 8, respectively, in fixed deposits, having interest rates of 10, 9, and 12% in some order. What is the greatest possible percentage by which the interest income of a person could exceed that of the other after 2 years? 5 is to 9 is to 8. So let's say this is 500, 900, and 800 rupees. You want to maximize the gap between the interest income of one person with respect to the other. So the question is asking you to do the allocation of the percentage rates so as to do that maximization. So the larger the income of the one person and the smaller the income of the other person, the larger will be the percentage gap also, right? So obviously the person who is earning, who has put the highest amount, if you associate the highest percentage to that, right, the higher will be his gain or income, right? So this is the principle. And the interest rates which are given but not in the corresponding order, but you have to decide the order. So the highest rate of 12% you would want to assign to that person who has invested the highest amount so that he gets the highest income. So he'll get 12% in 1 year, 24% in 2 years. So 2 years, 1 years does not matter. Effectively, the ratio of the income will be the same in any time period. So 12% you will associate with the person who has put the highest amount of 900, and the person who has put the smallest amount, which is 500, you would assign him the smallest percentage, which is 9. And you have to do the percentage comparison. So the income obtained by Sohan in 1 year will be 12% of 900. So that is nothing but what? 108 rupees. In 2 years, he'll get 216 rupees. In 1 year, Rohan will get 9% of 500, which is what? 45 rupees. In 2 years, he'll get 90 rupees. The ratio in either which way is the same. So the percentage comparison we can do, right? So with respect to 45, he is earning 108, which is how much more? 108 minus 45, which is 54. So how much percentage more? 54 he is earning more. Sorry, my bad. Just a second. Sorry, 63. Sorry, my bad. 63. 108 minus 45. He's earning 63 more with respect to his income of only 45 rupees. So what is the percentage gain? How much percentage more he has earned? 63 on 45 into 100%. 9 into 7, 9 into 5. So this is 7 by 5 into 100%, which is what? 140. Right? So a question in which you have to decide how to allocate, right? So very simple logic. Maximum rate to the person who has put the maximum amount, minimum rate to the person who has put the minimum amount so that the gap is maximized. Okay, so now time for some DS. Let's look at some data sufficiency questions. They come up in NMAT specifically, and we should be prepared for them. We have been doing them, and I've explained this many times how to go about these questions, right? So I'll give you a minute to try. Let's see. Here we go. Next one. All right. A, B, C, D, E. Statement 1 sufficient. Statement 2 alone sufficient. Both together sufficient. Each alone sufficient. Or nothing is happening, right? So please tell me your response on this one. I'll wait. All right, so I hope you're thinking on this one. If you get this, do let me know. Now, so yeah, so right, it's a question of coordinate geometry, right? On the xy plane, does the line L pass through 3 quadrants? Okay, thank you. Arup is saying D, Sushant is saying A. Let's check who is correct. Thank you, thank you. Let's check now. Statement 1, line L meets the coordinate x's at only one point. Under what circumstances is it possible that the line L meets the coordinate x's at only one point? There are three ways, very specifically. One way is the line is passing through the origin. That is one way. Another way is line is vertical, only intersecting the x-axis. The third scenario is line is horizontal, meeting the y-axis only. These are the three scenarios. Line is passing through origin, line is vertical, line is horizontal. Right? In either which way, in all these three cases, line is passing through exactly two quadrants. So I have a definite no to the question asked. No, definitely the line is not passing through three quadrants. It is definitely passing through only two quadrants, right? So statement 1 is a sufficient, right? It's a yes no question. We have got a definite no. In data sufficiency, we are looking for a definite answer. This is a data sufficiency question of yes no type. Does line L pass through three quadrants? Answer can be yes or no. We are looking for a definite answer. A definite no is also sufficient. A definite yes is also sufficient. Statement 1 is sufficient. Moving on to statement 2 now. Statement 2 says slope of line is non-zero and finite, basically implying that the line is neither vertical nor horizontal, because zero slope is there for a horizontal line, and a non-finite score, a non-finite slope is possible when the line is vertical. A vertical line, the slope is undefined, right? So the line is neither horizontal nor vertical. So it could be passing through origin and hence passing through only two quadrants, or it could be in any some other way like this and then passing through three quadrants. Yes, Arup, you realized your mistake. So therefore, in this case, the line may be passing through three quadrants or maybe passing through two quadrants. So both yes and no scenarios are possible. So this statement is not sufficient. Answer is A. Right. So very analytical DS question based on coordinate. All right. Perfect. Thank you. Thank you for your response. Let's see next one. Another question. Again, I'll wait for your answers. What is the value of 3x plus 4y? Very Very straight to the point question. Ah, ah. जो मैं सुनना चाहता था वो मुझे मिल गया. Thank you, Prabhakar. So, Arup, look at this. Obviously, each statement is not sufficient. Infinitely many values of x and y are possible with only one equation in the two variables. When you combine, obviously you can see that 4 and 5 satisfy over here, right? But do you know which is 4, which is 5? Either x could be 4, y could be 5, or x could be 5, y could be 4. The value of 3x plus 4y is not the same, it's different. So even after combining, the value of 3x plus 4y is not uniquely defined. It could be 3 4s are 12 plus 4 5s are 20, or it could be 3 5s are 15 plus 4 4s are 16. It could be 32 or 31. You don't know what is the value of 3x plus 4y even after combining, because the values of x and y are not still unique. They can be 4, they are 4 and 5, but do you know the order? Do you know which is 4? Do you know which is 5? That is what we forget when we are solving equations, right? That 4 5 comma 5 and 5 4 order does matter, right? Answer is E, not C. Perfect. So DS is very analytical. It is not just solve it, get it done, right? We are habitual of solving the questions. Here you have to be very careful. Are you getting the unique answer or not? Uniqueness is what you're searching for, right? Okay, so I'm glad that we had this discussion. I'm glad. I'm very happy that you're, you know, uh, you're active and you are enthusiastic, and this will take you far. So keep up your good work. Keep on up your practice. I'll keep on meeting you to refine your strategies. All right. Yeah, DS is tricky, right? Okay, so hoping to see you very soon. Make use of our mobile app, which is live now on both iOS and Android. Right? Thank you, people. Thank you so much. You are wonderful people. I'll see you again. Right? Thank you. And share with me your suggestions, any specific topics in which you want some help. Right? Thank you. I'll see you very soon. Bye bye.